Assalamu alaikum everyone. Welcome back to Easy Taleem. Today we are finishing the entire algebra section of Cambridge 9709 paper 32. Over the past few lectures we have covered modulus, polynomial or long division, factor theorems, remainder theorems, partial lectures on partial fractions, and now today we will be covering binomial expansion. This is going to be the final episode of the algebra series. Now here's something interesting. If Cambridge asks you to expand 2 plus 3x to the power of 8 as it used to in AS level, a lot of you will just smile because that's easy. But if Cambridge changes just one thing and asks you to expand 1 minus 2x, or let's just say that the same 2 plus 3x, and changes the power either to minus 3, which is a negative power, or changes the power of 2 plus 3x to a fractional power, which is just power half. Suddenly, you all will think it's a completely different topic, and it isn't. Today, you'll realize something very important. There is only one binomial formula. Cambridge simply changes the value of the power. So let's begin. Let us start with something familiar. Suppose we want to expand 2 plus x to the power of a positive integer, which is positive 4. Could we multiply it 4 times? Like 2 plus x times 2 plus x times 2 plus x and times 2 plus x. Can we do that? Of course, but should we? Definitely not. Cambridge expects something much faster. For every positive integer, we use the binomial theorem. So you guys should all write it down. So it is a plus bx to the power of n, and if a belongs to positive integers, this is the notation for integers. If n belongs to positive integers, then term r plus 1 is going to be NCR, n combination r, a power n minus r times b power r. That's it. This is probably the most important formula of today's lecture. Notice something: the power of a decreases. As you move on, the power of a is going to go down and the power of b increases with the subsequent terms, and the coefficients come from combinations NCR. So the first term is going to be NC0, the second is going to be NC1, and so on. So if you understand this formula, half the chapter is already finished. Now, if you were to expand this 2 plus x to the power of 4, if you do this, you are still going to get the same result that we have gotten right here, right? However, if you follow this formula, the binomial theorem formula, so for r taking the value 0 all the way till 4, so if the highest positive integer power is 4, and we will also learn something that if the powers are positive integers, then the expansion series is going to be finite. However, if it's fractional or negative, the series is going to be infinite, the expansion series. Now, r is going to take values ranging from 0 to the highest power of 4 in integer forms. So the first one is going to be tr plus 1. So when r is 0, so this is just going to be 4c0, 2 power 4 minus 0, x power 0, and so on. So we are going to get 16, 32x, 24, and when we are going to sum them all up, we are going to get this result. Now, let's do an example to explain. So let's say the examiner gives you a question like, let's find the coefficient of x squared in the expansion of 2 plus 3x to the power of 8. Now, it's not going to be wise to be expanding this entire thing. I already know that since x is in the second place here inside the bracket, and the powers are going to be in ascending order for x, so the first term is going to have x with power 0. The second term is going to have x with some, so the first is going to be a, the second coefficient is going to be b, some unknown b, which we will do once we start expanding it properly, but x is going to have power 1. So the fifth term is going to have the power x4 for some coefficient, let's call it d. So now, if you have to expand 2 plus, if you have to find the coefficient of x power 4 in the expansion of 2 plus 3x, all you need to do is find term 5, which exists at when r is equal to 4. So all you need to do is, it is going to be 8c4 times 2 power 8 minus 4 times 3x power 4. That's it. I don't know what the answer is going to be, but this is how you are going to do it. I want you guys to pause this video and try it yourself as well. So, are you guys done? Good. We don't need the entire expansion. because Cambridge didn't ask for it either. They are not rewarding marks to you for that. The power of x is 4. That immediately tells me that r equals to 4, or the term is going to be r plus 1, that is term 4 plus 1, that is going to be term 5. Now, when we substitute directly into the general term, all that we need to do is simplify. Put 8 combination 4 in your calculator, you're going to get a constant. Put 2 power 4, which is going to be 16, multiply that with the answer for 8c4, and then 3x power 4 is going to be something like, it is actually going to be 81 times x power 4, and that's going to be your coefficient once you simplify it. Notice we expanded absolutely nothing, and that's exactly how Cambridge wants you to think. Never do unnecessary work. Okay, so now let's take another example. Let's find the term that contains x power 5 in the expansion of 1 minus 2x to the power of 9. Now again, as the ascending order dictates, this is going to be the x5 is going to be the sixth term, right? So this is going to be term 5 plus 1, that is going to be term 6, and this is which is going to be NCR, n is 9, C combination, r is 5, a power n minus r, which is 9 minus 5, which is sorry, so this is going to be, we need the so 9 minus 5 and then minus 2x. Now this plus bx, which was the second term in the general form, is now same as minus 2x. So we have to put the entire minus 2x, this entire term, inside the bracket and raise it to the power of 5, which is r right here. Okay, so now whatever the answer for 9 combination 5 is, I'm not going to do that because that's going to take me time. So this is going to be some constant, but 1 power anything is going to be just 1, so I'm going to omit that. And minus 2 to the power of 5 is going to be minus 32. Make sure that you are not making any mistakes in dealing with the negative signs. Okay, and then x to the power of 5 is just x to the power of 5. Okay, so again, the power of x told us that r equals 5. That's all. Students often panic here, but the question has already told you which term to choose. Now substitute into the formula. You have to simplify carefully, and that's it. Finished. Now let me point out one very common mistake. Many students substitute r plus 1 instead of r. Why? Because the formula says t of r plus 1, as we were doing, right? No, tr plus 1 simply means the numbering of the term. The exponent still tells you the value of r, right? So if you're finding the x cube term and it is written like this, 2 minus x to the power of whatever, I don't know, it's 12. So x cube term, so r is going to be 3 and term is going to be 3 plus 1, that is 4. So this is going to be 12c3. A to the power a is 2, a to the power 12 minus 3, that is 9, and b to the power b is minus x, x to the power of 3. Okay, so that is how it is going to be. So if you so that tiny mistake costs a surprising number of marks every year. Now if, let's say, another example that just came to my mind, let's say you were given 2 minus 3x to the power of, I don't know, 11, and you have to find the sorry, this is 3x squared. Okay, now let's say that you were asked to find the term with of the coefficient for x squared. Now the coefficient, or let's say coefficient of x8, now you can see that the first power is going to be x0, the second power is going to be x squared power 1, the third power is going to be x squared power 2, the fourth power is going to be x4 power 2, right? So now for this thing, now we are dealing with, sorry, this is x cube power square. The fifth term is going to be with x4 power 2, right? So now we have to find the fifth term in here, right? So term 4 plus 1, so term 4 plus 1 is going to be term 5, which is going to be 11c5, sorry, 11c4, my bad. Yeah, 11c4. And then this is going to be a is 2, 11 minus 4 is 7, and minus 3x squared power 4. So this is going, so 11c4 has to be a constant, I don't know what. 2 power 7 is going to be 128, and minus 3 power 4 is going to be 81, and x squared power 4 is going to be, by indices rule, it's going to be x to the power of 8. So this right here is going to be the coefficient of x power 4 in the expansion of 2 minus 3x squared, the entire bracket, further raised to the power 11. So why do students fear this chapter, right? Because Cambridge changes one thing. Instead of asking positive powers, they ask negative powers. So what if you were given 1 minus 2x to the power of negative 3? Now you cannot apply, if you try to apply minus 3c0, you're not going to get an answer in your calculator. Or if you were given some fractional power, so 1 minus 2x to the power of 1 upon 3, if you apply this 1 upon 3c0, I don't know, anything in your calculator, you're not going to get anything, right? So students think the chapter has changed. However, it hasn't. Watch carefully. Now, suppose the question becomes 1 plus x to the power of negative 3, and I will just give it a label, negative powers. I want you guys to also write it down. Okay, right here. I hope the video is recording. Yeah, it is. Now see. So if you're asked to expand 1 plus x to the power of negative 3, and remember that I told you whenever the power of a bracket of a in binomial theorem or in the expansion of brackets is negative or fractional, then it is an infinite series, okay? Infinite series. However, if the powers were positive integers, just like the cases that we were doing here, then these are so this is going to have a total of 12 terms. This is going to have a total of 9 plus 1, that is 10 terms. This is going to have a total of 8 plus 1, that is 9 terms, right? So that is finite number of expansion terms, right? However, if it's fractional or negative powers, then it becomes an infinite series, okay? Now, or if you were given 1 plus x to the power of half, right? What's different? Only the value of n, that's it. Previously or in AS level or at the start of this lecture or previously in the previous sections, we were dealing with positive integers as powers of these brackets. However, now we are changing it to either negative or fractional powers. The same formula still works, exactly the same, but now something changes. The expansion no longer stops. It becomes an infinite series like I just told you. And there's another new condition. The expansion is only valid when this term is between 1 and negative 1, or the mod of this is less than 1, right? Because for this series to converge, this value has to be between 1 and minus 1, so that when you are expanding it infinitely, the subsequent terms become smaller and smaller. Please do not memorize this separately. Remember the idea: positive integer powers, finite expansion. Everything else, infinite expansion. Okay? Now let's do an example. If you were expanding 1 minus 3x to the power of negative 2. Now do not assume that we take it in the denominator and do it 1 minus 3x to the power of 2 and then rewrite it down as 1 minus 6x 1 minus 6x plus 9x squared. This does not give you anything. This doesn't mean anything. You have to bring it in the numerator, right? So do not go that route. Now let's see how do we expand this, okay? Now we replaced the n term with minus 2, so and x term with minus 3, right? Now follow the exact same formula. Nothing new happened, only the value of n changed. Notice the signs, notice the coefficients, which is minus 3. Take your time. This is where accuracy matters. Now Cambridge asks something else. State the range of values of x. Remember, inside the brackets we have minus 3x, okay? So now the range of values for which this expansion is going to be valid is going to be if this minus 3, sorry, I have to use a pen. If this, the mod of negative 3x has to be between 1 and minus 1, therefore x has to be, so the modulus takes care of the negative sign, so the modulus has to be between, so x has to be between 1/3 or negative 1/3. Always simplify it. That's another examiner favorite, okay? Okay, so far everything we have done, you've already seen before. You've seen positive powers, right? You have done Pascal's triangle in AS level, which was 1, 1, 1, 1, 2, 1, 1, 1, 3, 3. So this is 1C0, this is 1C1, this is 2C0, 2C1, this is 2C2, this is 3C0, 3C1, 3C2, and 3C3. And then similarly, so these produce 6, 3 plus 1 produce 4, this is 4, this is 1, this is 1. Similarly, 6 plus 4 is 10, 6 plus 4 is 10, 1 plus 4 is 5, 4 plus 1 is 5, and then 1. So this is 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, and this is what we call a Pascal's triangle. You have already done combinations in your AS level. You have done a general term. That's AS level. Now, Cambridge changes the game, right? And this is where a lot of students think they're learning a completely new chapter, but you're not. You're simply extending the same idea, and let me show you. So 1 plus x to the power of 5, right? So if we had to expand this, we will just come to this row of Pascal's triangle, right? So can we expand this? Yes, because the power is a positive integer. Now, what if Cambridge asks you to expand 1 plus x to the power of negative 3? Now, can I use Pascal's triangle? No. Why? Because tell me, how many rows are there in Pascal's triangle for negative 3? There are none, right? Exactly. There aren't any. What about 1 plus x to the power of half? 1 plus x to the power of half. Now, can I choose uh, half C3? Is this going to be possible? No. So using the combinations formula you have learned, not in the way you cannot use that for how you were taught that in AS level. So Cambridge now, or for not really Cambridge, but yeah, for such expansions where the powers are rational but they are negative or fractional, you are introduced to one new formula, and this is the only new formula you need to learn for the rest of this chapter. And this is what I've highlighted here as well. This is given in your MF19 as well, but I would rather that you guys know this by heart, right? And this formula is equally good if you are trying to apply it for your AS level positive power expansions as well, right? So that's fine. Now, this is the A2 binomial formula. So for powers which are rational and which are negative or positive or fractional, this applies, right? So the first term is going to be 1. And we are trying to do one simplification here, that whatever the first term is going to be, we are going to try to convert that into a positive, right? So that's going to make this expansion work. Turn this into a positive one, right? Now, so this gives us, so the first term is going to be just 1. The second term is going to be power multiplied by x power 1, right? The second term is going to be power multiplied by n, so n times n minus 1, and then we do a permutation of that. So we divide it, so we have to take away the permutation, so we have to divide it by 2 factorial, and then the second term is going to be raised to the power 2, and then n times n minus 1, n minus 2, and then divide by 3 factorial, and so on. So if this is a 7th term, all you have to do is you have to divide it by 6 factorial. So this was divided by 1 factorial, this was divided by 0 factorial. So the 7th term is going to be divided by 6 factorial, right? And the expansion is going to go all the way till n times n minus 1, n minus 2, n minus 3, n minus 4, and n minus 5. So 6 of them, 1, 2, 3, 4, 5, 6, right? And x is going to be raised to the power 6. Okay, so this is going to be our 7th term in the expansion of any binomial term in brackets, which is raised to the power negative or raised to any fractional power. Okay, now notice something beautiful. Instead of Pascal's coefficients, which was so 4C0, 4C1, 4C2, 4C3, 4C4, so the coefficients now generate themselves. Can you see? So this coefficient generated itself using this formula, right? So every new coefficient comes from multiplying by one smaller number, right? So whatever this was, you multiply this by this and divide it by 3. So this was divided by 2 factorial. 3 factorial may be written as 2 factorial times 3. So you will multiply it by n minus 2 and divide it by 3, right? So every new coefficient comes from multiplying by one smaller number. So now first coefficient is 1, second is n times x, the third is n times n minus 1 upon 2 factorial times x square. So students, you don't have to memorize 5 different formula. You only have to memorize one pattern. Every time subtract one more and divide it by 3 or 4 or 5, right? Because of this factorial in the denominator, and that's all. Now, another huge difference, the AS expansion always stopped. Like I told you, the AS expansions with positive powers are finite expansions, right? Why? Because eventually the bottom becomes so it becomes n minus n eventually. However, here that never happens. If n equals minus 3, the next coefficient becomes minus 3 minus 4, sorry, upon 2 factorial. The expansion after the coefficient after that becomes, so minus 3 times minus 4 is 12 upon 2 factorial is 6. So 6 times minus 5 over 3, right? So that becomes minus 10. Now this minus 10, the coefficient after that becomes times minus 5 upon 4, right? So that's going to go on, right? So nothing becomes zero, so the expansion is never going to end. That's why these are called infinite expansions. So from today, whenever you see a negative or a fractional power, a negative or a fractional power, your brain should immediately think not Pascal, not combinations, but this formula right here. And if this is quite dirty right now, I want you guys to go to scroll back to go back to the video where you could see a cleaner version of it and copy it down from there. Right now, let's do an example for this, so that we can see it in action. Right. So let's say we are asked to expand 1 minus 3x to the power of negative 2. Now, and of course, they're not going to ask us to infinitely expand it. They're going to ask us to, let's say they're asking us to expand it up to the term in x cube. So we have to do it up till here, right? So now the first term is going to be 1 because we already have a 1 here. So our case is, it's easy. Now the second term is nx, right? So n is minus 2, x is minus 3x. So we are just going to write that here. The third term is going to be n times n minus 1, which is minus 3 over 2 factorial and minus 3x to the power of 2. And then it's going to be minus 2 minus 3 minus 4 over 3 factorial times minus 3x to the power of 3. And now we already have a coefficient for 3, so we are not going to expand it any further, right? So now this is going to become 1 plus 6x, and this is going to become 2 times 3 is 6, negative negative positive, 6 upon 2 is 3. So 3 times 9x squared is plus 27x squared. And this term is going to be, so 3 factorial is going to cancel this, plus and negative negative becomes positive. Minus 4 times minus 27x cube is going to become 108, a positive 108x cube, right? Plus dot dot dot, c dots, we call it c dots. So this shows that this is going to go on and on and on. So the very first thing I always do, I write down n. So n was negative 2, right? So all the coefficients are going to start from here. So negative 2, negative 2, negative 2, right? So that is important. All the denominators are going to follow sequence as well. 1 factorial, 2 factorial, 3 factorial, and so on, right? So now, so this is, so the numerators aren't really changing, right? They are changing, but they are getting multiplied by one number that is one number less, right? So, but Cambridge isn't finished. They ask for what values of x is this expansion going to be valid, because this is so the expansion must converge, right? So you have to see this second term right here, which is minus 3x. So this has to be between 1 and minus 1, because can you see that these terms are getting raised to the power higher and higher? Minus 3x to the power of 2, minus 3x to the power of 3, minus 3x to the power of 1, right? Now, if x was beyond 1, what would have happened? This term becomes larger and larger because the powers are increases. However, if it is a term, the value of x is less than 1, let's say it is 0.8. So now when it is raised to the power 2 or raised to the power 3, the number gets smaller and smaller. So when your subsequent terms become smaller and smaller exponentially, the series is going to get converged, and that is how you're going to get an answer for a certain value of x if you have to approximate it. And we are going to do those when we come to Cambridge style questions, right? So in here we are going to write down, so the modulus sign is going to take care of the negative sign here. So we are going to do, so 3x has so x is going to be between 1 and 1/3 and negative 1/3. Okay, now you are never going to forget this line. Now, did you notice We never used Pascal's triangle. We never used combinations. Everything came from one formula, and that's the only difference between AS and A2 binomial expansion. Let's make it even more interesting now. I hope by now you would have understood why this new formula exists, right? This exists to take care of negative or fractional powers. How to substitute n, right, in the formula. So this is n times n minus 1. Let's say if it is n minus 2, so you have to divide it by 3 factorial, right? So you know all of that, right? Now, how to expand 1 minus 3x to the power of negative 2, right? You know how to apply this formula that we highlighted in pink above. And why modulus of x or was less than one third, or we could rewrite it as between one third and negative one third. And you would understand it better if you had gone through my lecture on modulus, which was the first in the series of P3 algebra. It's on in the same playlist on my YouTube channel, which is Easy Taleem, which this video is also uploaded in the same playlist. So I hope you go and check that out in order to get your concepts clear. Now, the next question you're going to ask me is, but sir, what if the expression isn't 1 plus x to the power of something, right? Inside the bracket, there is no 1, right? So that doesn't really matter, right? Why should this bother us? And this is where Cambridge starts separating your A grade students from A star students, right? So now, till the point that we had 1 minus 3x to the power of minus 2 and the likes, Cambridge was sort of kind to us, right? Every example looked like 1 plus x to the power of n. So life was beautiful. Everything used to fit perfectly. But does Cambridge always ask questions like that? No. Now look at this. So if you were given 2 plus x to the power of negative 3, I want you guys to pause the video, think in your head how to convert it into our desired form where the first constant term is going to become 1, right? Now, I hope you guys came up to the same conclusion. So I can take 2 common, put 1 plus x upon 2 inside the bracket, and raise this entire, or let's put parentheses here and square brackets outside as the norm dictates as well, and raise this entire thing to the power of negative 3. Now, what does that show us? By indices rule, both the terms inside the bracket, 2 and this bracket, is going to be raised to the power negative 3. So now we have our term, our desired form. So this is 1/8, and now we are going to expand it. 1 plus minus 3 times x upon 2 plus minus 3 times minus 4 times over 2 factorial times x upon 2 squared plus on, and then eventually when we are going to submit our final answer, we are not going to forget that this Masoom sa guy 1 upon 8 exists outside of the bracket as well, right? So make sure that you're not forgetting it. Okay, so you multiply the final thing with this. So now, could I use my formula immediately here? No. Why? Because my formula doesn't say that it didn't say that this expansion was valid for 2 plus x to the power of n. This was valid for 1 plus x to the power of n, right? X could be in any form, but the first term has to be a 1, right? Now, that 1 was not for decoration, it was essential. So our first job is, before we even think about expanding, is to create a 1, which we did, right? So now, again, 1 plus x to the power of n was 1 plus nx plus n times n minus, n times n minus 1 over 2 factorial times x squared plus n minus 1 n minus 2 over 3 factorial x to the power q plus so on, right? So this is what we do, right? Now, so we would have so we did this entire thing. I hope you guys came to the same conclusion here as well. Now, are we finished here? No. Cambridge is still going to ask you state the range of x, right? So when it asks you to state the range of x for this question, you don't have to state the range for x between that, right? You have to state the range for x upon 2, right? So we will do x upon 2 is less than 1, or x is less than, if we multiply both the sides by 2, so this is going to become this, or we will say that x lies between 2 and minus 2, because whenever x lied between x and 2 and minus 2, this expansion is going to become less than 1, right? These powers inside these highlighted terms, these brackets are going to be less than 1, and they're going to get subsequently smaller and smaller and exponentially, right? So this is one of the easiest marks on the paper, and I don't want you guys to lose it. If you have any queries, write down in the comment section and let me know if you guys have any queries, and I will further try to explain to you. Also, I on the Instagram we go by the name of Easy Taleem. I will write down the handle here. So on Instagram, we go by the name of EASYEZTALEEM. So if you have any queries, you can reach out to me in my DMs, or if you want real-time solutions, you can reach out to me on WhatsApp +92 329 3028485. And I also want you guys to promote this channel, subscribe to this channel, follow us on Instagram, and also in case you have any queries while you are trying to solve papers or trying to understand concepts for P1, P3, S1, S2, or whatever, you can reach out to me directly on my WhatsApp as well. It's free of cost. So now, can you already see a pattern? If I see 5 minus, we are doing another example, to the power of -4, or so what we have to do is we have to first factor the 5 out. So this is going to become 1 minus 2 upon 5 to the power of x, and then the entire thing raised to the power of -4. So this is going to become 1 upon 625, and then 1 minus 2 upon 5 to the power x raised to the power of -4, and then you expand it in the same manner using the P3 formula that I wrote above. Similarly, if you had 8 plus 3x to the power of half. So again, no rocket science here. You have to factor the 8 out. So you will have 1 plus 3 upon 8x inside the bracket, and then you raise the entire thing to the power of 1/2. So this becomes 2 root 2 when 8 is raised to the power of half, and the remaining is going to be expanded in the same. Yeah, okay, so we have not done fractional powers here, so I'll show you how to expand these as well. So let's make sure that you are not forgetting this 2 root 2 in any of these steps. Now the first step is going to be 1, because we already managed to get a 1 in the first place, and the second is going to be nx. So that's going to be half times x is 3 upon 8x. So I will write this entire thing down here, plus it is n times n minus 1. So half times minus half, which is n minus 1, half, and this divided by 2 factorial, and this is 3 upon 8x to the power of 2. And the third term is going to be half, negative half, and then further n minus 2, so negative 3 upon 2 divided by 3 factorial, and 3 upon 8 to the 3 upon 8x to the power of 3, and plus dot dot dot, right? That's it. Nothing fancy here. It's very easy to deal with, right? Now, Cambridge could also ask you to find the expansion in the first part, and then find the coefficient of x cube in the expansion of 2 plus x upon 8 plus 3x. This thing. You have already expanded this, so but you expanded this for a positive power. Now, this is similar to saying 2 plus x multiplied by 8 plus 3x to the power of -half, right? Now, what you have to do here is you keep this 2 plus x as it is, right? You factor the 8 out, so this becomes 8 multiplied by 1 plus 3 upon 8x raised to the power -half. I will put this outside this bracket. I don't want to omit any steps in this lecture so that it's crystal clear to everyone. 2 plus x. Now 8 is raised to the power 1/2. So this is 1 upon 8 to the power half, which is just 2 root 2. So I will, instead of writing, okay, let us just write it like this, and this is -half. Now I can make this into 1. So this is 1 upon root 2 plus x upon 2 root 2, and now multiplied by the expansion. Now this expansion is going to be 1 plus n. N is -half, x is 3 upon 8x, power 1, plus n times n minus 1, so -half times -3 upon 2, over 2 factorial, times x, which is 3 upon 8x to the power of 2. Now let's say that you are asked to find the coefficient of x squared in this expansion, for this expansion. So now this expansion is same as this, right? This last step that we have done. So now this x square will come if I multiply this x square term with the constant, or if I multiply the x term with x term here, right? So now let's take these two products. So now if I do the x terms first, so this becomes x over 2 root 2 multiplied by minus 3, which is minus 3 over 16x minus 3 over 16x. See how this will give us our desired x squared when two x power 1s multiply together. Now we will put a plus sign because we are taking a summation, and now very carefully we are going to multiply this 1 upon root 2, which is a constant, with an x squared term which is right here. Now this is going to be, so I can, so plus minus 1 times minus 3 is positive 3, positive 3 upon 4, and then upon 2 is positive 3 upon 8. So this is going to become 3 upon 8 here, and then this is going to become 9 upon 64 x squared. So this is going to become 9 upon 64 x squared. So if I take x squared common, what do I get? I get negative 3 over 16 times 2 is 32 root 2, right? Plus this is 3 times 9 is 27. 8 times 64 is whatever. I don't want to get into that. Probably 256, 512. So this is 512 root 2. So this is going to be plus 27 over 512 root 2, right? Now you can put it in the calculator. I can see that if I multiply, okay, so I can multiply and divide the first term by, wow, so 32 times, so this is power 5, 6, 7, 8, 9. So I have to multiply it by power, so multiply and divide by 16. So this is going to give me 27 minus 48 over 512 root 2 x squared, 512 root 2 x squared. So the coefficient is going to be 27 minus 48, that is going to be negative 25. No, or no. So this is going to be 48, 28, whatever that is going to be. Right now my brain is not braining. You guys can do it in your calculator, right? 18, yeah, 21. Oh my god. So this is negative 21 over 512 root 2 is going to be the coefficient of x squared in the expansion of this fraction, this entire fraction, right? So this is the maximum that Cambridge asks you, right? So that's it. You don't have to do anything else. First factor this 8 out, then you apply the formula every single time. Never expand first. Always create 1 plus something here to the power of whatever the power, right? Fractional or negative, right? Now, so we have dealt with the negative powers, we have dealt with fractional powers, we have also dealt with when you have something in the numerator and then something in the denominator. Usually the question is going to ask you in part A of a binomial expansion question that expand 8 plus 3x to the power of negative half, right? And then the question is going to ask you that what is going to be the, I don't know, what is going to be the coefficient of x squared when you expand this 8 plus 3x under root. Now this 8 plus 3x under root is same as if this numerator was multiplied to this and you had already expanded it. So you just write down that here, and now instead of multiplying all those 4 terms that you found in part A, multiply those 4 terms with 2 terms here and get those 8 terms, and then find out the coefficient of x squared from among those. Think intelligently. A constant has to be multiply with an x squared term, and x1 term has to multiply with an x1 term in order to produce the coefficients of x squared, and then you take the sum, and that's it. Now, before we finish, I want to leave you with something that I wish every student knew before walking into the examination hall. Cambridge is not trying to trick you with 10 different binomial expansion formulas. They're asking you one simple question. Can you recognize the type of expansion? Let me show you. So if the power is a positive integer, So 1 plus x to the power of n, then it is quite simple. Or let's say 1 plus bx to the power of n, then it is quite simple. Term r plus 1 is going to be equal to ncr a power n minus r and bx to the power of r, and that's it, right? So is if you have a positive integer in the power, then you should immediately think of combinations, right? This is AS level, Pascal's triangle, general term, and it's a finite expansion done. Now suppose your power is non-integer, so it is non-positive integer. Okay, so this is for non-positive integer set, so it is not that, right? Maybe it's a fractional power 1/3, maybe it's a negative power, let's say -4 or something, right? Now your brain immediately switches to the A2 formula, which was 1 plus x to the power of to the negative or fractional power is same as 1 plus nx. I'm writing it down again. I want you guys to copy it down in case you forgot the last time, upon 2 factorial and x to the power of 2. Now x represents whatever is here in the second place. You could have 52 upon 61 x squared here. So in place of x, you will write 52 upon 61 x squared and then further raise it to the power of 2 here, right? So I'm just saying. And then n times n minus 1, n minus 2 over 3 factorial, and this second term, which is x to the power of 3, and so on. This is an infinite expansion. It doesn't end. Range of validity, it is modulus of x, whatever this second term right here is, has to be between 1 and -1. That's it. 2 rows, 1 decision, nothing more. Now ask yourself one more question. Does the expression already begin with 1? If yes, great. Use the formula immediately. If no, stop. So if you have 2 plus 3x to the power of -5, all you have to do is you have to factor the 2 out first, so that this becomes 2 times 1 plus 3 upon 2x, and this entire thing is now raised to the power -5. Apply the power, so this becomes 1 upon 32, and this becomes 1 plus 3 upon 2x to the power of -5. And now your x right here, right here, right here, this now becomes 3 upon 2x. So you apply the formula accordingly, right? So you have to, in such a case, you have to factorize first, and then you create 1 plus something, right? Only then expand. Never ever expand first. Now, one final question. Does the examiner want the entire expansion? Usually no. Read the question carefully. Maybe they only want the coefficient of x cubed. Why would you go on expanding? Even in your AS, if some student is watching, or if you're considering a positive power, positive integer power, why would you consider expanding the entire finite series? An infinite series, of course, you cannot really expand all the terms. So all you have to do is identify the coefficients in the expansion that you need. So if you are being your expansion is multiplied with 2 plus 3x, and your expansion is and you need an x cubed term, so you should already see that an x cubed term here must multiply with a constant 2, and an x squared term must multiply with 3x here in order to produce two terms with x cubed as the variable attached to the coefficient, right? So the examiner probably just wants the coefficient of x cubed, right? Maybe they just wants a constant term. Maybe only the first 4 non-zero terms. Only calculate whatever the examiner asks. Every unnecessary line is another opportunity for you to make a mistake, okay? So here's the checklist I personally use in every binomial question with my class. Question appears, you see whether it's a positive or rational power, right? So if it's a positive power, so you apply the combination formula. If it's another rational power, of course, which means it is not 1 plus x to the power of pi, right? You cannot do that. This is not part of our syllabus. So if you have a rational negative or fractional power, then you can't apply Pascal's. You don't need Pascal for that. You need your A2 P3 formula, right? So, and for range of validity, of course, you understand that the second term with the variable, whatever that is, some bx has to be less than 1. And if you have seen my modulus formula, you will notice that this is same as 1 upon b, x lying between 1 upon b and -1 upon b, right? So expand only as far as is required. If you do these 5 things, this chapter becomes one of the highest scoring topics in Pure 3, and examiner usually allocates 4 to 7 marks for these questions. Now, With that, we have officially completed the entire algebra section of Cambridge 9709 P3. The entire algebra section has been completed. So we did modulus, as I told you at the start, we did polynomial division, right? And everything was leading to the second, right? Polynomial division. We did the factor and remainder theorems, right? Factor remainder theorems, where factor was a special case where the remainder was 0, right? We also did partial fractions, and partial fractions usually are going to be combined with binomial expansions, because you get 1 upon 2 plus x and then minus 3 upon 5 plus 2x, something like that, and then they will ask you to expand this and expand this. So you have to bring this in the numerator, which is going to give it a negative power, and then you're going to expand it using the P3 formula. And then last one was binomial. We did 2 lectures on partial fractions for its different cases, and then the last one was this binomial expansion, which we covered today. So if you have genuinely worked through every lecture, not just watched them, you have built one of the strongest foundations for P3. But Pure 3 isn't over. Next week we begin a brand new chapter on logarithms, exponentials, logs, exponentials, and linearization, right? Linearization. Okay, we'll cover it in 3 complete lectures. Okay, sorry, I dropped my mic. And exactly in the same manner, starting from first principles and ending with Cambridge exam questions, right? Even if you're not enrolled with Easy Taleem for our October-November retake batches for 26 or for our May-June 27, I'll continue sharing the key ideas publicly, because my goal is simple: to help as many math students in CAIE and Edexcel as possible understand mathematics instead of memorizing it. If this lecture helped you, leave a like, subscribe to the channel, and share it with a friend who's preparing for October-November 26 retake or sitting for May-June 2027. I'll see you guys in the first lecture of our next chapter on Monday. See you.